Hey everyone, thanks for joining us and welcome to Introducing GraphQL for Gloo Edge and Gloo Mesh. My name is Keith Babo. I'm a product manager here at Solo.
And my name is Sai. I'm a software engineer here at Solo.
All right, we have an action-packed agenda today that we've broken up into 4 parts. First, Sai is going to kick us off with a brief introduction to GraphQL, just to give us a foundation for folks that are new to GraphQL, or maybe it's just a quick refresher for everyone to lay a foundation, make sure we're talking about the same terminology. Then I'm going to come in and talk a little bit about Solo's perspective on GraphQL and how we feel we can help our customers deploy GraphQL successfully. Then Sai is going to come back and talk about the key use cases and features that we're working on right now. And then finally, I'll wrap up with details on the Gloo GraphQL roadmap, along with details on our upcoming beta. All right, so let's jump into it. Sai, what is GraphQL?
Thanks, Keith. Most simply put, GraphQL is an API protocol. We can compare GraphQL to the REST API protocol that many of us are familiar with. In REST, we make a request for a specific resources state. In this case, we are searching for a list of businesses' resources from the Yelp REST API. The server responds back to us via HTTP response in a response that looks something like this, a giant JSON blob. And this makes sense. The endpoint didn't know exactly what information we wanted from the backend server, so it gave us everything. Depending on how the backend is designed, it can serve up to kilobytes of information. Now, this may not matter if we are working with a gigabit connection that can handle such large data responses. However, over 55% of web traffic is generated from mobile devices, and much of that traffic comes from areas where broadband internet connection is scarce, and even the best connections serve 2G speeds. To compound the effect, the HTTP hypermedia links or front-end logic will chain multiple requests together to fetch the entire object data model. For example, here we're creating separate requests from the mobile client for a business's menu, its reviews, and any possible events occurring at the business. Resolving all 3 of these requests is a costly operation, time and compute-wise, from the user's perspective. So how do we solve this problem? Well, this is where GraphQL comes in. The benefits of GraphQL are twofold. GraphQL APIs return exactly what we need and nothing more. And the GraphQL server can fetch data from across different resources given a single client query. So even if an object's data model is distributed across multiple microservices, the GraphQL API can present the object to the client as a unified API. Let's take a look at this in action. Once again, we're going to use the Yelp API, but this time we're going to query the singular GraphQL endpoint that Yelp provides. GraphQL's queries are extremely customizable, and here we show that the server provides us only the data that we ask for. Here we query for any businesses that might be named Solo, and we're just asking for the business name for now. The server responds with potential businesses with names that we might be looking for. Now let's say we want the phone numbers to these businesses. It's as simple as that. Let's continue to dig into the business object model and ask for a location. In this case, GraphQL can also query across multiple APIs for a single resource. Here we have a business location API, which serves business location information. Notice how the GraphQL query only queries the API when information about the location is needed, and then provides the aggregated data to the client as a single response. If the GraphQL server were not here, the client itself would have to issue the location request, but GraphQL saves the mobile client the round trip. GraphQL also provides some other wonderful functionality, such as aliases, so that we can name the data whatever we want. In this case, we're naming the query solo query, which is also really useful in the case where we want to issue multiple of the same queries. In this case, we're issuing a business search for any businesses named Solo, as well as a software search for any businesses named software. And the JSON response follows that alias pattern. Now you may be wondering, how do we construct these queries? Is there any way of knowing what the data model is like? For example, REST APIs can be defined using the OpenAPI spec, but there's no consistency across all REST APIs. So how does GraphQL solve this? Well, GraphQL is typed. It provides first-class support for API specifications through its type schema. So what does this look like for GraphQL developers and consumers? Well, GraphQL has its own simple language for easily defining object data models and relations. For example, every single field in a query is defined in the schema. This begs the question, how does the person or application issuing these GraphQL queries know exactly what the schema looks like? And REST endpoints often expose a separate endpoints such as /swagger.json or /openapi.json to serve the OpenAPI schema. GraphQL schemas support introspection, which means that GraphQL servers provide first-class support to clients that are interested in seeing what the schema looks like. This has many benefits. First off, error messages can be extremely smart and efficient at diagnosing problems with queries. In this case, we have a typo in our query. It also provides the functionality of autocomplete through interactive playgrounds such as Graphql or GraphQL Playground. And these playgrounds also allow you to browse the schemas freely and construct your queries using the schema browser. The technical benefits that GraphQL brings to application developers are evident. It can speed up your application development workflow. In fact, these benefits have led to explosive growth over the last several years, establishing GraphQL as a leading choice for new APIs in organizations. GraphQL was only publicly released 6 years ago, but is already being used by 1 in 4 large organizations. Lots of companies have decided to adopt GraphQL, some of the early adopters being, of course, Facebook, where it was created, Shopify, Instagram, Pinterest, Twitter, and GitHub. And of course, there's many more large enterprises that have gone on board with GraphQL, and it's easy to see why. So Keith, what does Solo bring to this technology, and how do we make it easy for you to switch to GraphQL?
All right, thanks, Sai. Great question. So when we talk to our customers and just really look at the market in general, we see 4 primary adoption patterns for GraphQL. I'm going to list these in order of probably complexity and maturity, but this doesn't have to be the specified order that you follow, and you may employ multiples of these patterns simultaneously. So we're just going to talk about them in order of complexity. So the first one is the easiest and is really appropriate for starting out when you have maybe your first step with GraphQL, you have an existing REST API, and even a single REST API, as Sai was mentioning, can have a ton of data that your front end doesn't need. So as a first step, you can put a GraphQL server in front of that, have a GraphQL API, and let the client and the front end determine what data they want to consume. This is a great first step when you look to actually start growing your graph beyond just a single API. So we go from a simple monolith maybe to a composed monolith where I'm bringing multiple back-end data sources into my graph with resolvers. And those back-end APIs could be a bunch of REST APIs, it could be gRPC, it could be Lambdas, it could be a mix of APIs, but I'm bringing all of those APIs into a single graph in a monolithic GraphQL API. Once I've done that, the next step, and as likely when I'm scaling GraphQL within teams in my organization, is I start to see a lot more GraphQL APIs. In other words, there are bits of the graph across the various teams in my organization. And so the next step is actually to federate those subgraphs into a unified graph. And that federation, there's a number of technologies that can enable that. There's Apollo federation, but there's also schema stitching as examples. Ultimately, the goal of these technologies are exactly the same, which is that you are trying to create a unified graph from a selection of individual subgraphs in your organization. Now, this is starting to get pretty advanced and pretty mature when it comes to GraphQL adoption, but there's one pattern left. And that pattern is when you start to think about how you are scaling GraphQL and a unified graph across all of your deployment environments. So that's on-premises, that's private cloud across the cloud providers, and even looking at partner and SaaS APIs. All of these data sources collectively contributing to your unified graph that you're presenting to clients. This is complex and powerful, not only from a GraphQL perspective, in terms of getting a unified graph, but also from an application networking perspective. How do I bring all of these disparate environments together and the data sources that exist there into a single unified data plane? So one other thing we want to talk about in terms of what we see with customers is those are the adoption patterns for GraphQL, but what about the network topologies and the traffic patterns? And so there's really two principal patterns that we see. And once you see them, it won't be particularly surprising. The first is north-south, right? So we're standing up a GraphQL server. That GraphQL server is talking to one or more upstream APIs. Here we're talking to the products API. And then we stick a proxy in front of that GraphQL server to be the point of ingress or the gateway to the GraphQL API. Likewise, we also see the case where potentially in a mesh environment, you have an east-west traffic direction. So in that scenario, the GraphQL server and the API are deployed as independent deployments in the mesh. And of course, they talk through sidecars. So any conversation between the GraphQL server to resolve data in the REST API is going through the server sidecar and then back up through the product sidecar. Whether you deploy one or both of these mechanisms, the constant here is that there's always a proxy in the mix. Why is that? Why is there a GraphQL API is perfectly capable of exposing a network endpoint where you can invoke that data and get that GraphQL data? So why is that? Why is the proxy always in the picture? And the reason for that is a GraphQL server is only half of the complete picture for exposing GraphQL APIs in a secure, reliable, and scalable way. So what we see on the left of this picture is what the GraphQL server provides today, which is all of the awesome benefits Sai was describing earlier in the presentation. But on the right are all of our existing application networking policies that we must have for any API that is exposing business data or valuable customer data outside of our network boundaries. So things like rate limiting and authentication authorization and web application firewall rules, data loss prevention, caching, all of these controls that we implement in the proxy layer today need to be combined with the GraphQL capabilities in the server. So when we see this environment in our customers and discuss with them their concerns and considerations for deploying GraphQL, we start to think, what's a fundamental way that we can help and assist our customers in adopting GraphQL? And one of the primary ways that we can help is by treating GraphQL as a layer 8 protocol that is understood directly in Envoy. And so what we've done to achieve that is we've implemented a GraphQL filter in Envoy that performs as a full GraphQL server. No need for a separate GraphQL server deployment. The filter itself fully understands the GraphQL language and protocol and can service your GraphQL requests. Now, what benefits does this offer? And I just want to talk about a few benefits here. The first is a drastically simplified deployment architecture. I can't tell you how many times we talk to customers that begin to struggle even in the tens when they get to GraphQL APIs and individual GraphQL endpoints. When they're standing up tens, forget hundreds and thousands, even at tens of GraphQL server deployments and starting to deal with the sprawl of managing those additional deployments, right? How do you keep them up to date and enforce consistent policies? All these concerns come with a separate deployment for the GraphQL server. So what we've done is we've eliminated that entirely. No need for a separate GraphQL server deployment. You can just use the proxy that you've already got deployed today for GraphQL. A corollary to that is that because we've dropped the extra GraphQL server, we've eliminated a network hop. So not only are you not dealing with that extra network hop, but because the GraphQL filter is implemented natively in Envoy and C++, you get blazing fast performance at the data plane. A really nice additional benefit from a development team standpoint is that because this is programmed just like the rest of your application networking policies via declarative configuration, there's no need to write code. You're actually just writing YAML and Kubernetes custom resources that you apply directly to your environment that you can check into your source control, like to Git or whatever you want to use, and then automate via continuous delivery and GitOps the deployment and provisioning of those environments. So the application teams don't need to worry about that. Can be fully automated. So your application dependencies and your infrastructure can be treated as code and configuration that's checked into a source repository. Another benefit of this being in Envoy is all the other features our customers are using today, as I mentioned, for rate limiting and security and all the other great filters we have implemented. You can do that in the proxy and implement that policy consistently across your GraphQL endpoints and APIs in your organization. If you're doing this in code, you're relying on every application team binding to libraries and configuring those in a way that's consistent across the GraphQL landscape in your org, which is prone to failure. We can do this in a single place in the proxy today, and we can automate that. So it's super, super powerful. Finally, the last point I'll mention, if you go back to the phases of GraphQL adoption, we just want to highlight that at the earliest phases of GraphQL adoption, the architecture we have with Envoy is perfectly suited for basic use cases. If you're standing up a simple monolithic GraphQL API, proxy's already there. It's super lightweight, super easy to get started. Yet that simple architecture scales all the way to composite APIs, through federated APIs with stitching, all the way to hybrid multi-cloud and multi-cluster environments where we have a unified control plane in the mesh that spans all of the environments. So a single solution here that's going to grow with your usage, and it's going to fully support you in your first steps with GraphQL, all the way to the long game of global multi-cloud deployments. All right, Sai, so how about you want to talk about some of the key features that we've implemented and that we're working on today?
Yeah, definitely, Keith. And I'm also going to talk not only about the key features that we've implemented in GraphQL server or in the proxy server, but also some of the features that you get out of GraphQL being part of the Gloo Mesh and Gloo Edge ecosystem. So first off, Solo provides key GraphQL language support in its GraphQL server. This makes it easy for a team to migrate their current GraphQL solution over to any Solo GraphQL product. In addition, like you mentioned, GraphQL server and config management is all declarative. This means that all your GraphQL resolver configuration, route configuration, and schema config can all live as YAML resources that you check into your GitHub repository. This means that your GraphQL platform teams can now receive all the benefits of a GitOps workflow, including configuration change reviews, history and changelog tracking, as well as an easy way to revert back to a previous Git commit in the event that a bug is introduced into the system. For more information on GitOps, make sure to also check out the Weaveworks talk about GitOps with Gloo Edge. Gloo GraphQL also makes it especially easy for customers to migrate from existing APIs over to GraphQL APIs without ever touching a line of application code. We call this schema discovery and auto generation. Let's say you have a gRPC, SOAP, and REST API microservice running in your Kubernetes cluster. Gloo can discover these API specifications and definitions and translate them directly into GraphQL schemas and resolvers. So now your clients can issue GraphQL queries to the GraphQL server, and the server will handle translating these queries into the respective API protocols, as well as translating the responses back into the GraphQL response, JSON response that the client expects. You can check out a live demo of this working during our hands-on with GraphQL workshop led by Admin Keith. In addition, we also provide a developer portal UI to manage, view, and play with your existing GraphQL APIs, as well as a wizard to create new ones from scratch or from existing services. Now let's zoom out a bit and talk about the architecture of a GraphQL deployment in the Gloo ecosystem in various scenarios. Here we have a gateway deployment where our proxy is processing and routing GraphQL traffic from a mobile client to various applications. Notice that these applications haven't been touched or modified and still serve gRPC, SOAP, and REST traffic. But the mobile client sees GraphQL responses because of the GraphQL translation that happens in our proxy layer. In addition, we can also take advantage of existing layer 7 functionalities, such as external auth server to authenticate requests, as well as our rate limiter. We can also use WAF rules to further protect our applications from untrusted traffic. In addition, we can add CDN level caching using GraphQL prepared queries and a Redis cache database. So now that we have a GraphQL server in the network proxy, we can improve this model further by moving to a service mesh architecture. If you have a Gloo Mesh and Istio deployed to a cluster already, then your service mesh sidecar proxies turn into their own GraphQL servers, The Gloo Mesh gateway is then able to expose a gateway GraphQL schema, which is an aggregation of all the services GraphQL schemas, so that the mobile client is able to access the services as if they were one unified GraphQL server. A great example of this, which I encourage everyone to play with, is the GraphQL GitHub Explorer, in which they expose all their services in one unified GraphQL schema. So why not make our model a little more sophisticated? Here we have a multi-cluster deployment of Istio and Gloo Mesh, and this is where Gloo Mesh really starts to come alive. The Gloo Mesh management plane is able to manage all the gateways across Kubernetes clusters and keep clusters configurations synchronized across permission spaces, such as security, user clusters, and public cloud. So now essentially you are clicking a button and saying, I want users with X or Y authentication to access the accounts and users service in the user clusters, but not in the public cloud or security clusters. And Gloo Mesh will automatically do the hard work of creating gateway schemas that expose only certain parts of the entire API to certain users. We also introduced this concept of workspaces, which are essentially namespaces, but across clusters. A team can own a workspace, so now teams don't have to worry about cross-cluster management, because that is taken care of by the Gloo Mesh automation. For example, the payments team can grant access to the accounts team for a subset of their GraphQL services, or part of their GraphQL schema. Essentially, GraphQL and Gloo Mesh allow for more sophisticated level 8 routing and configuration management to allow your applications teams to develop faster without having to worry about the underlying infrastructure and configuration management. So Keith, what's on the roadmap for Gloo and GraphQL?
All right, I'm excited now, Sai. That was great. And let's talk about what's next. So first, we're really, really excited to announce the beta release of Gloo GraphQL with the Gloo Edge 1.11 beta. You'll see a blog announcement with all the details around how to register for the beta and get access to the bits. But we really wanted to focus quickly on what are the capabilities that you'll be able to get a hands-on with here when you get that beta build. As Sai mentioned, we've got the Envoy filter and the language support he covered, support for REST and gRPC resolvers, that really nice declarative API that's just minimal level of config to get GraphQL APIs wired up and ready to consume for your front-end teams. Really helpful productivity tools like discovery and auto generation of GraphQL APIs from OpenAPI upstreams. Core metrics for GraphQL, really nice caching in the resolver tier to eliminate like refetching data in the course of executing a query, eliminates N+1 sort of query issues for your upstreams, minimizes the load on those upstream data sources. The UI that we saw, which is really great, which also includes schema registry capabilities. So when you're looking to browse the catalog, the graph for your organization, you can see all the individual schemas that are comprised and available within your organization. And then finally, wiring into the other application networking policies we have in Gloo Edge, things like XAuth for authentication authorization, and then data loss prevention or DLP for controlling the data that gets outside of your network boundaries. So that's what's in the beta. When we're looking at what's coming next, well, the next step, the immediate next step is getting this to GA, which will happen in the 1.11 release of Gloo Edge. In that release is some of the stuff we're working on right now that will show up actually in a refresh of the beta as well. But things like schema stitching that Sai mentioned. Also, two exciting additions to our caching support. So I mentioned resolver caching, but also the ability to cache and via persisted queries and cache controls CDN compatible responses. So what that means is that I can issue cache directives or specify those within the configuration, and then also provide a HTTP GET or CDN compatible persisted query that my clients can execute. So the very first time they execute it, it'll go into the upstream data sources. And then when on the response path, that can get cached in the CDN, and then further requests within the cache controls will actually go to that CDN. So really helping to lighten the load on your infrastructure. And then also the ability to integrate with the caching support coming in 1.11 to support caching directly in Envoy itself. So response caching for GraphQL and other API types directly inside Gloo Edge. Finally, we'll be doing some web application firewall policies for things like query depth protections, and then query cost analysis for rate limiting of GraphQL queries to complement our existing rate limiting and WAF support. After that 1.11 GA release of GraphQL capability, Very next step is to bring this capability to Mesh. So we're already implemented in an Envoy, and we just need to do a few things with Mesh to really fine tune and provide the best experience for integrating with things like the V2 API in Mesh and the concepts like Workspaces that Sai discussed earlier. We're also looking at integrating with our developer portal, so you can have a really nice self-service kind of view documentation, interactive query browser and explorer, sign up for API keys and stuff for GraphQL APIs. We feel like we can, based on our existing developer portal, can have a market-leading solution there for GraphQL. Enriching our tracing information with GraphQL spans, so in the resolver tier and query execution phases, adding those spans. Looking at additional resolvers like custom resolvers made in WASM, the SOAP, looking at Lambda and database resolvers, a lot of other great ideas in talking to customers of other resolver types they want to have. And last but not least, continued feedback from customers. We had great experience with customers so far, working with their use cases and requirements to build out this capability. And we're looking forward to continuing to do that with your hands-on experience in the beta and the feedback you provide us. So thank you very much. You're 100% responsible for our continued success here. Okay, so this was just the tip of the iceberg, believe it or not, at SoloCon when it comes to GraphQL. There's 3 other sessions you really want to attend to get that next level of detail. The first is the Secure Gateway and GraphQL Server talk by Kevin and Adam. If this is a one-on-one talk, consider that like a 201 or 301 talk where they're getting really low and getting into the details. That's going to be super useful. Sai and I have another talk on GraphQL. This one focused more on developers and how they adopt GraphQL and how the way we're presenting GraphQL is particularly attractive to developers and simplifies their everyday workflows. And then finally, there's an actual workshop in Instruct that Adam has created that will allow you, without installing anything, you can just go to the Instruct environment and try out all these really cool features before you get your hands on the beta. And that's all we have for today. So thanks very much and looking forward to talking to you soon.